Hello Physics 1, this is our group project. My name is Danjuma.
My name is Joshua Livingston.
I'm Stephine Mathis.
I'm Precious Effiong.
I'm Cory Adeniyi.
Okay. So for this experiment, we're going to be comparing the work done in moving a book across a horizontal plane, moving the same book up an inclined plane, moving a book vertically against gravity. And for this experiment, we're using a uniform distance of 1.43 meters. We're disregarding friction, and we're working with a constant force of 10 newtons in each demonstration.
What is work? Work is done when a force that is applied to an object moves that object. The work can be calculated by multiplying the force by the amount of the movement in the object. Mathematically, you can write this as F multiplied by D equals work done.
In this video, we intend to show how gravity affects the work done over a uniform distance. The results will show the difference in work done moving the book horizontally, up an incline, and vertically at a uniform distance.
Hello once again, I'm Paul, and here we're going to be pulling the 0.7 kg book across the 1.43 meter table.
Hello, my name is Joshua Livingston. I'm going to do the calculations for the first experiment. As previously stated, work is equal to force times distance. Our force of the pulling, if we're going to assume that it is 10 newtons and that the distance is 1.43 meters, then we can set this equation up this way. Times a distance of 1.43 meters. The work done moving this book is 14.3 joules. Hello once again, my name is Joshua. I'm going to be pulling a 0.7 kilogram book up a 30-degree angle for 1.43 meters at a constant force. Next, we will perform the calculations for the inclined plane problem. As you see, work done up the inclined plane is work equals mass times gravity times this height. Now, this height is not given to us. All we have is the hypotenuse in this problem, which is the 1.43 meters. So we can find h by using trigonometry. Sine is equal to opposite over hypotenuse. This right here is the opposite. So sine is equal to h over 1.43 meters. Now, 1.43 meters times sine of 30 degrees is equal to this h value. This h value is calculated to equal 0.715 meters. Now, we can plug h into this formula up here. Now, work is equal to mass times gravity times the height of the inclined plane. 0.7 kilograms times 9.8 meters per second squared times 0.715 meters. Work is equal to 4.9 joules.
Hello guys, this is Cory again, and today I'll be pulling this 0.7 kilogram book of 1.43 meters high.
Finally, we will perform the calculations for experiment 3. Work is equal to the mass times gravity times height. Gravity is a constant, the mass is the same, and the height is the same. Work is equal to 0.7 kilograms times 9.8 meters per second squared times the height of 1.43 meters. The work done lifting this object vertically is 9.81 joules.
Notice that each formula we use is essentially the same thing. Work equals mass times gravity times distance. And we use the same mass for each of them, and gravity and distance. Yet each value work done was different.
Since the sine of 30 degrees is a half, it explains why work done in experiment 2 is half of the work done in experiment 3.
The value for experiment 1 is greater than the values for experiment 2 and 3, and logically this should be the least amount, but considering we use hypothetical values, we are not able to get an appropriate answer for this experiment.
And this concludes our demonstration of calculating the work done value in different scenarios.
We hope
We
you
hope you
enjoyed
enjoyed
it.